Our next speaker is Steve McIntyre with his talk, Don't Fear the Secure Boot. Over to you, Steve.
Thank you, Chris. So, I'm Steve. Quite a few of you probably know me. I've been doing UEFI and then secure boot stuff in Debian for, oh my God, more years than I care to think about. It mostly works. I want to talk to you about UEFI secure boot, what that means, why it matters, and try and fix or try and challenge some of the misunderstandings and misinformation that we get from time to time. I then will talk about some of the issues that we have and some things that are coming in the future. There is so much information here I could waffle about for another couple of days. I'm going to try and focus. There's a lot more information. Please ask questions at the end and I will try and answer whatever questions you have. I might, however, just redirect you to existing docs or apologise and go and write some. So, what is UEFI? Who here thinks they know what UEFI is? I'm with Simon, yeah, hand wave, not looking quite sure. So UEFI stands for the Unified Extensible Firmware Interface. That is the actual point of UEFI, is not an implementation. It's the set of interfaces that it defines. You can go away and write your own implementation of firmware underneath, and so long as it implements the right APIs here, or ABIs as well, then it should work. There's a test suite for it and everything. One of the key things with EFI, as it was at the time when Intel first developed it for the Itanium platform, was they knew that BIOS APIs were a bit rubbish. They were a bit limited they were very limited. And there were so many issues that they didn't just want to bodge. For a start, it was all defined in 16-bit assembly, on x86 only, in 16-bit mode. And, there's a stack of things like that. Have we got audio? Because I can't hear myself. Okay, fine. So they defined a set of APIs. Some of it can be more complex than people are comfortable with, but they defined APIs, there's a test suite, everything. You can go and run the test suite and validate that your implementation works, if only all the vendors did. So there are two sets of APIs, and this is a deliberate situation, it's a deliberate choice. You have UEFI boot services. These are available, guess what, in early boot. These are things where you can go and allocate memory. These are low-level interfaces. You allocate memory. You can probe and see what the hardware is doing. You set up the memory maps and things. You go and load things off disk. You run them. Later on, you can also call UEFI runtime services. Now, in fact, you can call runtime early boot and later, but there is an very important call, which is exit boot services. That is the hint from your bootloader or kernel or whatever to say, and now you're finished. At the point when you call that, the world flips. Suddenly, all of those pointers that you might have to UEFI boot services don't work anymore. If you try it, yeah, things go bang in interesting ways. I'll come to why this matters in shortly. So as I say, there is a reference implementation of UEFI, which is EDK2, which is the EFI Development Kit version 2. It's called, people call it interchangeably, they call it Tiano Core. Tiano Core was the project who took over the maintenance from Intel, and there are lots and lots of people working on it. It's good. It's horrifically complicated in places, and it all looks like Windows source code, but hey, it's source code, all of it's available, you can do really cool things with it if you know what you're doing. So, what is secure boot? Hands up here who thinks they know what secure boot means. This is actually easier, so this isn't a trick question. So fundamentally, UEFI Secure Boot is there for one reason and one reason only, which is to protect against persistent boot time malware. We've all heard of, back in the day, boot sector viruses. If with your virus, your malware, you can infect the boot sector of an Intel PC, of an old, DOS machine, didn't matter what people did after that because you've hooked everything else underneath. So they can do whatever the hell they like. You're underneath, you've got control. So back in the day, yes, you'd have your, silly message would pop up on screen to say, aha, I own your computer. These days, of course, people are more sophisticated. They'll tell you that while they're encrypting the hard drive and, exfiltrating all your information, ransomware, all of the evil stuff. This is what this is part of a solution to. It's not the complete solution, but if you stop people getting persistent boot time malware on a system, you've at least got a chance of doing useful stuff later. So quite simply, each bit of software is verified by signature. The firmware verifies the first stage bootloader. The first stage bootloader will then either verify the second stage bootloader or by calling APIs will cause the firmware to do that validation. So on and so on and so on until you get to a system. So this is just then a problem with key management, and we know that's all a solved problem, isn't it? So as I say, the point of this is that you can use this as a base for further security solutions. Not everybody wants that, but for the people that do, you can measure everything that runs later and verify it's doing the right thing, the expected things. You can lock down a system completely, so every single program that runs must be signed. Again, that is not great for general purpose systems like, the laptops we're carrying around and developing on. But if you're running something like a kiosk system, a cash machine or something, you probably want to make sure that the only binaries running on that system are ones you know about. There's a lot of use cases here. So, key management. Microsoft, from history basically, have ended up defining a lot of this. Most x86 PCs at least come with Microsoft keys included. I'll come to those in a moment. Microsoft ended up taking on the job here of being a CA, a certificate authority. That is not a light thing to pick up. It takes a lot of effort and there are a lot of costs with being a CA, particularly in a situation where the vendors using your software will not be happy if you fuck up. If you break their systems and cause them to have to either reflash a lot of systems before they ship to customers, or God forbid, you cause them to have to recall those systems because you screwed up, the costs of that could be ludicrous. So this is not a job for a small company. Lots of people were already trusting Microsoft because, for better or worse, this is where this started. Lots of people were shipping Windows systems. Therefore, yeah, well, we're already trusting Microsoft, we'll do that. In the Linux world, we don't necessarily have that same trust, but this is the world we live in. So that was where we started. A lot of ARM64 machines are also using Microsoft as a CA for the same reasons. There was discussion about trying to find somebody else who might act as a CA, and there was a lot of people stepping back rapidly. Nobody wanted to be on the hook for potentially, very large monetary settlements in case they screwed up. And, well, look, Microsoft know how to do this already. We'll let them do it. They'll be happy. It's how we've got there. That mostly works. There are more things, however, coming. The way that the keys work, this is all defined in the UEFI Secure Boot spec. There are multiple key rings. These are not necessarily the best way of organising things, but it's what we have. There's the platform key, the key enrollment key, the DB, which I can never remember what it stands for. This is the actual signature database, and the DBX, which is the keyring of things that we must not run. That's your revocation database. I don't want to go into all the details of how they work. That's beyond the scope here. But these are terms that you will hear and you will find if you go looking online in the documentation. The two root CAs that are currently in common use, the Microsoft keys as I mentioned earlier, they have their own root CA which they use for Windows, and they have the third-party UEFI CA, which is what they use as a root of trust for everybody else. I'll come to more on these later. On most machines, however, you can modify the set of trusted keys. This is part of the spec for an x86 machine, at least. If to get the Microsoft logo, you must be able to modify the keys here. That can be very powerful. So, what is Secure Boot not? Again, there are some misunderstandings here. This is not a way to lock people out of their own machines. You know, I mentioned about the fact that you must be able to enroll your own keys and manage what keys. Also, the thing that is a requirement for the logos is you must be able to turn off Secure Boot as well. So this is not a way to stop people using Linux or FreeBSD or DOS or anything on their own machine. However, for those people who do want security, and that's not just Microsoft, this includes the Linux distros and a lot of people, particularly a lot of corporates, a lot of large customers, a lot of large organizations really want this kind of feature. They want security. They don't like boot time viruses. They want to actually to be able to validate that the software they're running is the software they know. This is all good. So, how does Secure Boot work on a Linux machine? I am not even going to go into the Windows side because frankly, that's boring and I don't think anybody else here wants to hear it. So, we have a piece of software called shim. Matthew Garrett, who is very well known throughout the community, wrote the first version of shim. Other people have contributed to it a lot over the years. Fundamentally, it is the first thing that will be signed by Microsoft. It then acts as a new root of trust, and it includes extra keys, certificates that you can then use to validate anything else that comes later. It will by default use the existing 4 keyrings I already mentioned. It will also add the machine owner keyring. Lots of people around here are looking at me, you know this stuff already. I hope I'm not being too boring. The machine owner keyring is really, really cool. It means that you can sign your own binaries on your own system and they will be trusted. Isn't that awesome? And you know, it's an important feature. So further programs after shim are then signed using the new keychain that you've added to the system using your shim binary. So the typical ones will be grub, firmware upd, the kernel image, UKIs, unified kernel images. I'll mention those a little bit more coming. The point of shim here is to be a small bootloader that does nothing magic. The source code is small enough to be auditable. Believe me, I've read all the shim source code. The crypto bits that get hash included from OpenSSL are, oh God, I don't want to go there, but you can understand what shim is doing directly in its own source code. I wouldn't recommend everybody does it, but there are a lot of people out there who do read it and validate it and verify it regularly because it matters. The final important thing about shim, and this is a horrible legal crap, it's BSD licensed. Microsoft are happy to sign a shim. They will not sign a grub binary because it's GPL licensed. Okay, so what's the process of getting a signed shim? You can, well, in fact, of using Secure Boot, I'll come to the signed shim in a moment. You can use your own keys. It's perfectly possible, as I said. The mock database is really useful. So if you're doing anything on your own machine, you're building your own kernels, you're developing kernel drivers, whatever, and you want to check that this works, you can either add your own keys in the firmware. That's perfectly doable. There's documentation out there. We have documentation that will describe how to do this. And on competent machines, the interface is going to be painful, but you can add your own keys, and then your things are trusted just as well as anybody else's. This is good. You can put your key into the mock database. That's actually easier. You never need to go to firmware. Shim already knows all of these, already knows how to manage keys. You just say to Shim, here's another key, trust that. And you do need to be in physical charge of the machine. You have to go and validate at initial boot on the console and say, I trust this. Again, we don't want people doing this from user land and maybe doing this remotely. This is a feature. That all works, but what's the problem? This doesn't scale. If you've got one machine, it's fine. If you've got 5, oh, it's a pain. If you're an organization with thousands of machines, or you want your software to work on every machine on the planet, this clearly doesn't scale. So the next option is to get yourself a signed shim. How hard can it be? So there is a process that is defined for this. It is forever being slightly improved and slightly and worked on as more people go through this. But fundamentally, you have to build a copy of shim. The source code is all available. Your binary build must be reproducible. This is really important. We all like reproducible builds, don't we? Because, of course, when people come to look at that, they will want to reproduce your build. If they can't reproduce your build, they have no trust whatsoever that what you say is in that binary is what's actually in that binary. You know, this is good. This is reproducibility. We all understand that piece. So you do your building, you submit it for review. There's a lot of paperwork or a lot of process around that. There's a lot of attestation that you need to do. You talk to Microsoft and you go through their process too. Microsoft admitted some years ago that all of these shims that people were asking to be reviewed and signed, they didn't know what they were looking at. And that's fair. You know, we wouldn't know what to do with a lot of the Microsoft source, Windows source code either. So what we agreed a few years ago was there would be a trusted shim review team made up of the shim developers who would look at any given submission, validate that it looked okay. So yes, that's actually shim. No, people haven't patched out all of the key handling, that kind of thing. And we would then say to Microsoft, yes, that looks good. Microsoft would trust that team for that side of things and would then do the validation on, is this person actually part of that organization? You can try and claim to be HP or Lenovo, you won't get very far. If all goes well here, this can take a while, there's a lot of things involved, you'll get a signed binary back. Now, I am quite invested in this. There is a shim review team, it's done by volunteers, I might be the person in charge of it. Not necessarily because people wanted me to, but it's a volunteer thing, and I did the typical Debian person thing of, oh, nobody's doing that. Nobody's doing that. Oh, oh God, I guess I'm doing that. And this is how the world works. We know this. So we now, for a while, there were only 2 or 3 of us doing shim reviews, and there were a lot more submissions coming in than we could cope with. But we now have a lot of good people who are working with me, doing a better job than I am, I'll be honest. and actually helping to review the shims. We have a more formal process that says you don't just get the approval of one person, you get multiple reviewers, and they have to agree that what you're submitting looks okay. Now, what we're looking at here now, and again this is expanded, it's not just does your shim binary look okay, we want to know what kernel patches are you applying to enhance secure boot. That grub binary that you say you want to boot, oh, actually, that doesn't have all the security patches that we want. Try again. Iterate, and it can take a while. Believe me, some people in this room will know just how long it can take. Eventually, you get a shim. You should get a signed shim binary back, and then yay, that's it. You're done. Yeah. No. You don't just get to have a single grub build or a single shim build and expect it to run forever. The only way that we can keep security here is by keeping on applying new fixes. Now, because this is not just part of your normal OS image, we don't just apply fixes, we also have to revoke the old binaries. Because your old binaries may have security holes in, I say may, did have security holes in, we have to roll out revocations to the system that stop maybe the firmware or maybe other shims from loading those old binaries. This is a painful process, but it's necessary. Microsoft went through this recently. I'm sure lots of people here will have seen the story where they revoked some older shims themselves. We have in Debian revoked older shims. If you might not have noticed yet, if you have updated to the latest version of shim signed in Bookworm or Bullseye, you can't boot any older versions because we have explicitly revoked things that we know to have security holes here. It's not fun, it's not nice. I know it's really inconvenient for some people if they want to go back to older systems, but this is how security, unfortunately this layer, it's about the only way we can do it. Now, revocations are hard. You know, I mentioned the DBX keyring earlier. That's easy. That's just a signed set of revocations in your system, and here are a set of checksums of binaries that you don't want to run anymore. That's fine, isn't it? You've got plenty of storage space in your UEFI variables. It'll all be good. No, it's not. Unfortunately, this is actually a design flaw in the UEFI secure boot spec, and the people who were there at the time have admitted this, that it's great when you think you might have two vendors and they might need to revoke something once a year or something. The world moved on. We now have dozens of Linux distros with dozens and dozens and thousands of different binaries. We've got shims, we've got grubs, we've got kernels. The only way to be secure here is to revoke them. Even if you're only adding a SHA-256 sum of a particular binary into that database, you could be looking at megabytes of storage. The flash where your UEFI lives has 2 megs. Checkmate. It doesn't work. And it's a problem. So we have a new scheme, I say new, a replacement scheme in the Linux world called SBAT, which is Secure Boot Advanced Targeting. That is a clever way of revoking old binaries. Every binary that you have on the system will include SBAT data to say essentially what security version or what security level it is. And we have one variable on the system that defines a minimum set of standards for those SBAT variables. When we decide, no, that version of Grub has a hole in the JPEG loader that could let somebody get around secure boot, once everyone has applied fixes, hopefully, we will eventually roll out a new update that stops any version of Grub prior to the fixed one from running. And this actually does work. It works so well that Microsoft love it too. They're on board with this. They're looking at something quite similar themselves, and this should, touch wood, would hopefully even get standardised. It's being submitted to the UEFI people to go there. That would be great. So now we can push revocations out periodically. They might be from firmware updates. So as you get new firmware from your system vendor, this can include revocation data. That will typically be the DBX. But we might also get revocations, as I said, using SBAT. Shim itself can enforce a minimum level of SBAT. That's what we just did with the shim signed in Bookworm and Bullseye. Or other software can do it too, like the Microsoft Boot Manager. So essentially, the thing to take away from here is, remember, shim and grub and all of these will not be trusted forever. We have to keep on rolling updates. We have to keep up to date. And then people want LTS distros and everybody cries. The fun thing about this is it's not just your system once it's installed. If you want to now go back and start and install installation media from an older build, it doesn't work anymore. That's a problem. It means that the enterprise distros, the LTS distro folks, are going to have to keep on generating new installation media, new live media or whatever, for any system that is taking continuing support. We know this is painful. Microsoft know this is painful. They've just had to start telling some of their big corporate customers that, you know, that rescue media that you have, it's now dead. Try again. And again, that doesn't sound too bad if you're a small IT shop. If you're a large organisation with 100,000 machines, and a lot of teams, and you've got to track all of this, it's painful, but this is security. There is no other way of doing this. So, with all of this pain, is Secure Boot worthwhile? Probably. I can't say it's always worthwhile, but for most people, absolutely, get on board. It's worth it. You don't have to. Again, as I said, systems are designed such that you should be able to disable these things. You should be able to enroll your own keys, but it's much better to enroll your own keys that you trust than it is just to turn it off. If you have a system that has an undetectable, boot time malware, you cannot trust that machine from that point onwards. And it gets even harder to fix than in the old days on an old DOS machine or old Windows 95 or whatever. If you threw away the hard drive it was installed on and started again from scratch, that's fine. It's not so easy anymore, because these days you've got things in NVRAM, you have storage in places where you never did before. It can be quite difficult. It's absolutely worth turning this on and using it, even if it causes issues. Hibernation is hard. How do you trust a hibernation image? Because where do you store keys? People are working on it. SUSE people have this working now with TPM storage for the hibernation keys. We haven't got this yet, but as patches are going around, we'll take this soon. Loading third-party kernel modules. Well, guess what? If they're not signed, they're not coming in. Kexec. Guess what? If it's not signed, you don't get to boot that. This is a problem. The other things are more subtle. Direct access to memory and I/O ports. Well, if you've gone through everything to sign all the binaries, but then the system lets you go and prod various bits of memory, your security's just gone. Loading unsigned DTBs, device tree blobs, on an ARM system. Again, that can fundamentally change how device access works, and no, we'll have less of that. These are all problematic for people who do this all the time. Some of these are solvable, like I said, hibernation. We can store keys. If you want to load a third-party kernel module, the NVIDIA driver is a particular common one here, then you'll need to work out signing for that. These are just about all solvable, but it's more effort. Yay, effort. that, unfortunately, the bad people are why we don't get nice things, or why we have to work harder to stop them doing those bad things. One of the reasons I wanted to do this talk is to try and clarify and deal with some of the misunderstandings, and I will say misinformation that we sometimes get. These are paraphrased quotes from things that I've seen on mailing lists and in IRC. Secure boot is just designed to lock you into Windows. No, it's not. It might have been by some people initially. We talk to Microsoft regularly. They care about Linux people being secure just as much as about Windows people being secure. Some people might not believe me when I say that, but it's the people working on this stuff just want the bad actors to be locked out, full stop. Secure boot adds more vulnerabilities. This is hilariously awful. The person saying that pointed at a bunch of CVEs which were just, here are some secure boot bypasses. Turning on secure boot did not add any more vulnerabilities. It was literally, these are the places that we need to fix so you can't work around secure boot. That's all. Secure boot doesn't work if you're using testing. What? Every binary that we sign goes through the normal Debian release process. It goes into unstable. We sign binaries via a process in unstable, then they migrate to testing when we're ready, then they go into a release. It all just works. There's nothing magic there. Or the last one here, secure boot doesn't protect the average user. Well, do you do banking on your computer? Do you want to store your personal data in a way that won't let random idiots on the internet steal it and encrypt it so you can't get back to it? I count that as useful protection. Big corporates can do even more than this, but at the very least, do the basics. So, there are challenges. These are real problems. We've all come across, those of us who ever played with any of these, we've come across broken UEFI implementations. Things where no matter what you do, the machine will still try to boot Windows because that's all the firmware vendor ever tested with. Or, oh yes, I will happily let you write a boot variable, and then I will ignore it. Or, oh, unless you do this particular binary in that particular location, I will, no, there's nothing to see there. Where's the Windows install? We've now got new ways for firmware vendors to get things wrong. They don't need help, but there's now more complexity. So these are, I'm not going to name names. The people involved will know who they are, and you will have seen stories on the internet in the last year about people who are using broken keys. There are some vendors who have shipped test keys, trusted, on a lot of machines. There are some vendors who have leaked their private keys for things that are used for signing a lot of systems. And it's how Debian people, I've had people laugh at us in the past at how paranoid they think we are about how we handle our keys. If I was a firmware vendor and I'm signing software that is going to be going on to 1 million systems a week, I'd want to be careful with them. Apparently no, not everybody does. And then of course mishandling revocations. Revocations are hard, I'm not going to argue, we know that. But still, think about what you're doing here. Now the next challenge is a fun one. This is really fun. Key management. Yeah, again, it's a solved problem until it's not. The existing 2 Microsoft CAs are going to roll over soon. Can you imagine how fun that's going to be? Systems that you buy today will still be using those keys. If you want to get your shim signed, or if you want to boot your signed Windows loader, again, I'm not being particularly choosy here, it's going to be signed with one of those. What happens when we get to the rollover date? In a lot of cases, we don't know. Some firmwares genuinely don't validate dates. Or you might just change your RTC and then it's all fine, isn't it? Microsoft have been working on this for a while. It's a complicated process, made even more complicated by the fact that we don't know, no single organisation has a complete set of machines, you know, including all of the different firmware builds, so we can validate what happened when. So there are simple things you could do, like just, so start signing things with the old CA and also the new CA. We know there are machines out there that will go bang if you try that, because nobody thought about it and nobody wrote it in the spec, and even if it was in the spec, some people would do it wrong. This is interesting. There's going to be a lot of fun. Look in the press in the next couple of years as these start to come out, and there's going to be a lot of people with having very bad days. And then revocations. You know, I keep on saying revocations are hard. They haven't got any better during this talk. So, future stuff. We have a lot of cool stuff that is going on, and there's more cool stuff coming. So far, we don't yet have NX no execute support at firmware level. Now, this is something that people have been doing for years and years and years in user land and in the kernel, but we didn't have this at the UEFI level. It's coming. It has a whole bunch of issues, including, guess what? We don't actually have many firmware implementations that do this right. We're testing, we're going through, NX will be a requirement on for Microsoft signing shims before too long. It should have already happened, but we had an exception because we knew that we couldn't make it work yet. Again, if you're going to go back to ancient versions of Red Hat or old versions of Debian or Ubuntu, you're going to have a problem here, because unless the entire boot stack is tagged and supporting NX, this can't work. This is a problem. There's a lot of discussion, a lot of work going on to make it happen as best we can. ASLR, address-based randomization. Again, this is awesome. This is something that insecurity people, they did like 10 years ago. We haven't got it yet. It's coming. Next piece is unified kernel images. At the moment, we boot shim. We then boot grub. We then boot a kernel with the initramfs, and then we go into user land. Each of those pieces will be signed individually, not the initramfs. This is the way to do that, is you can combine your kernel, your initramfs, and also an important piece of configuration, the kernel command line, get baked into one binary that you can sign. This is, again, great for security for the people who want it. For those of us who like to be able to tweak their kernel command line, for example, this is less good. There's a lot of discussion going on as to exactly what might happen here. We're probably going to end up in Debian with UKIs as well as Linux and grub and initramfs. Watch this space. As we go further forward, we're going to see more use of the TPM, the Trusted Platform Module. I assume most people have heard of that and understand what it is. Again, I am skeptical. Most of you don't know what it is, because I can't say I do. But key thing is, it's a piece of hardware that can give you better trust on your system. And you can identify you and your system better by having a secure space for keys and measurements and stuff. Other distros are already doing more of this. This is a place where the whole of the Linux ecosystem is picking up on these things, because genuinely there's good security. Or good security improvements to be had. Architecture updates. So we've had in the past an AMD 64 signed shim, and secure boot, of course. We did have i386, but to be honest, we stopped doing that because nobody else did, and it doesn't work very well. You're hearing that from me. We have ARM64 signed secure boot. For those so far small set of machines that actually will use it, it's great. For the other ones that don't actually do anything with it, it's a pass-through. You don't notice. Like Steve's talk about security features in ARM kernel and ARM user land, for most of these things, it doesn't hurt you to have it on, even if your system doesn't enforce it. If your system does enforce it, this gives you a lot of extra good stuff. And then, better handling of revocations. You might have heard me say that R word quite a lot today. We have ideas on how to do better revocation handling in future, and instead of it being done as part of your shim binary, such that it will revoke older binaries on your system, we're looking at probably, because this is still under discussion, we're going to end up with the distros shipping out signed revocation updates, probably through FRUPD, and it then has a lot more control. At the point when it's running in user land, it can actually go and have a look and see what else is on your system, rather than saying, oh, I'm in early boot, yeah, it's fine, we can turn all of those off, and then the user doesn't know what's happened. We can actually give much more control to users and get better results here. So, Vince had cat pictures earlier. I've got much better. I've got a dog picture. Do we have any questions here? Before we go through that, there is a lot more information about the stuff I've written on the 2 wiki pages. There will be more when I get more time. My slides are all online. Ian.
So, firstly, thank you for trying to explain this. However,
Yes.
so security software is not generally neutral. Sometimes we could like it wholeheartedly. Often one needs to have a more careful approach. Here, I think we have some very big problems. So you might very well think that some of the things I'm about to say are FUD, but I think they're very real concerns. The first is that I think it probably is true that at least some of the people who invented this originally were seeing it as a way to help defend Microsoft's monopoly. It is true that a lot of the people working on it now are not trying to do that, but the fact that this is making our life harder disproportionately than it is making Microsoft's life harder is not an accident. It's a feature of the design, and it's also a feature of the fact that the whole system is more or less controlled by Microsoft. Even recently, we had, I read some blog post from Matthew Garrett the other month where he was basically pleading with Microsoft not to do a shitty thing. And, well, that didn't seem great to me. In terms of benefit to users, particularly our users, now, I mean, correct me if I'm wrong, but I've not heard of a great prevalence of post-grub Linux boot time malware that, replaces your Linux kernel with some weird thing. That doesn't seem to be a thing that exists. It would probably be a thing you could build, but people don't seem to have built it. It's probably complicated and difficult. All of this business with signing the kernel is defending us against a wholly theoretical attack. And the main effect of it is to make it harder to do shit and making everybody's lives more difficult. So on that level, it doesn't seem like a very good balance of risk. So I think my overall opinion about this is that probably we and our users would be better off if it didn't exist, or at the very least, if it was limited to maybe signing bootloaders. Okay. Microsoft have decided that it should cover our kernel as well, and we haven't been allowed to make that decision. And there's one final point I wanted to make. So there's a lot of this stuff here about, control of your own computer. A lot of this stuff has been designed by very corporate people in very corporate kind of contexts. And one of the design goals is to allow a corporate to provide its employees with systems that those employees can't control and that are controlled by corporate IT. And again, here we have an example of a thing that is not politically neutral. Now, legally speaking, those computers are the property of that corporation, but if it comes to the conflict, you know, if there is some struggle between somebody who's using a computer every day and the corporate overlords who have hired them, I'm on the user's side. And much of what's going on here, particularly like the unified kernel image stuff, is really very helpful for a lot of use cases that I consider actually harmful and that I'm ideologically opposed to. So, frankly, you know, maybe not all of it can die in a fire, but like, I would be very happy if most of this died in a fire.
Okay, that's fine for you.
Thank you.
I will say, for example, that there are demonstrable cases where, you know, people have demonstrated attacks. This is not theoretical, where without something to protect the system right from the get-go, and what we have, the something we have today is secure boot, you can absolutely replace your grub loader, you can replace your kernel. And what we want to get to here is any random root hole on your system should not then be allowed to escalate into a persistent malware that can mean the attacker owns your system from that point forward, no matter what you do. That's what people are trying to stop here.
That sounds like a laudable goal, but those attacks aren't out in the wild, and that attack is almost indistinguishable from the user uses sudo and becomes root and intentionally changes the configuration of their system. And it's difficult for the software, and particularly the security system, to know the difference. And that's why there's a balance to be struck between defending against certain attacks and allowing the user to continue to control the system that they're sitting in front of. And in this case, because you know, you say these are attacks, but they're basically like, I can install a new version of Grub. That's not an attack. That's a design feature. And what this is doing is effectively reclassifying that as an attack, because on the theory that I, as an end user, probably didn't intend to do it, and so it probably is an attack.
So this does come down to a choice. If you don't have something to control what might get installed or what might get run, then you don't get to make the choice. You can't stop other people doing it. If there is the option of secure boot, you can willingly choose to disable it, enroll your own keys. In the vast majority of systems that are out there, you can do that. We all know of systems, as I said, there are firmware vendors who get it wrong. For decent systems out there, this
so we
gives
have
you
people who have been harmed, as in can't install the software they want, but we don't have people who have benefited, because there aren't attacks in the wild that, for example, kernel signing is defending our users from. So the balance of harm versus benefit is not in the system's favour.
I think we'll have to agree to disagree there.
I think we probably will.
Okay, thank you for your comments, Ian. Simon. Oh, sorry, I thought I saw him first.
I just wanted to respond to what Ian was saying. If I was if I was nefarious and at Microsoft and wanting to lock people out in the way you've described, and the system I would construct would not look like secure boot as we have it. The rational thing to do there would be a system that looks more like, for example, the Apple ecosystem, where you or smartphones that have locked bootloader or that kind of, like, these already exist. We know about these systems.
Microsoft
This is not it.
They need plausible deniability as well. Right? I mean, and the thing is, the people who started...
No.
Okay.
No. Right, Andy.
You were talking about it being extensible.
Yes.
This is awesome. You're talking about more features coming in over time. This time last year, we were talking about at some point there will be a purely hypothetical, it does not yet exist, but it's a good idea to have a defence against, a quantum machine. Do we have the ability to add alternative signature schemes, alternative authentication, for example, PQC?
Yes, in most cases. Unfortunately,
Specific, obviously the implementation is dependent, yeah.
yes. The limiting factor on most of these things is, guess what? Firmware. Some of the firmware teams out there are lovely, some are not. I'm not going to name and shame because that would be inappropriate right now.
Yeah, understood.
Recently, Microsoft upgraded the SBET level from 1 to 4, and then there was I was also active in that reply series. As Debian, we do every 2 months, every 3 months, depending on the stable or old stable, a new release, which means that we will have, if we are really unlucky, a whole of 2 or 3 months that our newly released images will not work if someone is a distro hopper or a Microsoft double boot user. And do we intend to do in some future, say at 12.8.1, within a few days with just the SBET level increased?
If we have to do that, then we might have to do that. The particular case that happened here, I will explain. Microsoft did, as Roland said, they bumped the SBAT level from Boot Manager because of issues. There was an attack called Black Lotus, which was a way of breaking secure boot, then coming round and using older distro binaries to come back in and then load attacks against Windows and other distros. They had not been blocked yet via the normal revocation route with DBX, so Microsoft put it into a Windows update for a newer version of Boot Manager, and unfortunately didn't quite get it right. What their code was meant to be checking for was any dual boot systems and not apply that update on those dual boot systems. As we've spoken to the engineers involved, and believe me, I've spoken to the engineers involved, we have regular calls between Microsoft and the distro secure boot people, we realised that their algorithm was wrong. And so some systems were blocked from booting Linux by accident. It's possible to fix this, and there's documentation online of how to do it. If you reboot your system with secure boot disabled, that will actually undo that change, and then you can step forward again. But obviously that's not great. We don't want to be telling people if there's a problem, disable secure boot, it's all fine. That's a mistake. We all know that. In our particular case, we already had a new Debian shim that was in review and was ready to go. And unfortunately, we missed the window for 12.6 by a couple of weeks for unrelated problems, mostly me cocking up, I will freely admit. And then it meant that we didn't have a new shim out in time. So there was a window there for a couple of weeks where if you had one of those Windows systems and due to a code mistake, it didn't see your dual boot Debian system, it could have locked you out. Nobody wants that to happen. That is a mistake, and people are working on better solutions in the future. If we end up with this happening again, then yes, we may end up having to do a rapid update, but a rapid update when it's going round with signing and review and everything is not what you think it is. It's not, definitely it isn't rapid. Okay. Steve, last question. We have like a minute left.
Oh, okay. I was going to very quickly embarrass you and say I've got some very grateful colleagues who are very thankful of the work you've done with shim. They tested it out at the 15.8 fix landed in SID and it landed in testing. It's helped some of my guys out, so thank you.
Awesome. Thank you very much. Right, and I think we need to stop there. Thank you all. I hope that wasn't too tedious. As I said, there's more information online, or please prod me after.